This is the screencast for section 5.5, example 1. In this section we're going to explore the law of sines. The law of sines says that for any triangle, specifically we're going to use this for non-right triangles, the sine of an angle divided by the length of its opposite side will equal the sine of another angle divided by its opposite side. So in other words, the proportion between, or the ratio between the sine of an angle and its opposite side is always the same. I put a note on the front page here. These are not right triangles. You cannot use Pythagorean theorem. You can't use sine as opposite over hypotenuse. You can't use cosine as adjacent over hypotenuse, etc. Make sure that you are checking your work in these. A couple rules to follow are the smallest side is always across from the smallest angle, and the largest side is always across from the largest angle, and then by default the medium side is across from the medium angle. In example 1, the information that we are given on this triangle is, first of all, it is not a right triangle. We are not given a right angle here. We know that angle A is 36 degrees, angle B is 48 degrees, and side A is length 8. So we technically have an angle side situation. So we can set up the sine of an angle and its opposite side, the ratio, because we know that. So the sine, we know the angle and its opposite side. So the sine of 36 degrees divided by 8 is going to equal the sine of 48 degrees, which is angle B, over side B. So now all I have to do is cross multiply. And B is going to be 8 times the sine of 48 degrees divided by the sine of 36 degrees. In my calculator, I make sure that I am in degree mode, and I get that B is about 10.11 units long. Whether that's feet or inches, I don't know. I'm going to put that over here. Now, I technically know that side B is 10.11, but if I use 10.11 as a rounded value in my next setup, the answer that I get on this next part is going to not be as accurate. So I'm going to start again with the same exact ratio as I used before. The sine of 36 degrees over 8 equals, now I'm working to find angle C and side C, because I know angle B, side B, angle A, side A. Angle C can easily be found by taking 180 degrees, the total angle degrees in a triangle, subtract 36 and subtract 48, and I'll get angle C is 96 degrees. So now, since the sine of A divided by side A is proportional to any other sine of the angle and its opposite side, I can take the sine of 96 degrees, divide by side C, cross multiply, oops. And in my calculator, I get that side C is about 13.54 units. So now I have successfully solved that triangle. The now try problem, example 1, has also an angle side given information. The angle and its opposite side that I know from my given information is angle B and its opposite side. So I'm going to set up the sine of 45 degrees divided by 3.7 is equal to, now I know angle A, so I'm going to say the sine of angle A, sine of 60 degrees divided by A. Now I can cross multiply again. Make sure I am in degree mode, and I get A is about 4.53 units. Now, the other setup, let's see here. I am going to start out again with the same ratio I did before. The sine of 45 degrees divided by 3.7, the length of side A. Now I need to find angle C again, so I'm going to take 180 degrees minus 60 degrees minus 45 degrees, and I get angle C is 75 degrees. So I have the sine of 75 degrees is going to be divided by side C, and I can solve for side C. Now I plug all this in my calculator and I get that C is approximately 5.05 units. Now in checking my triangles, as I mentioned before, you have to make sure that the biggest angle is across from the biggest side, which is true, and the smallest angle, which in this case is 45 degrees, is across from the smallest side. And as you can see back in example 1, the same held true. The biggest angle is across from the biggest side, the smallest angle is across from the smallest side of 8.